In this video I will show you how to use the Auralization panel in AlphaCell. So first of all, open AlphaCell and open a study, for example like this one, which computes the sound transmission loss in diffuse sound field of a partition, which is only 8 mm. It's a plasterboard, and we have of course an echoic ending here, and the result is here. You can see the Auralization panel here. You can click on it, and you need at most three things to hear the sound computed by AlphaCell. So first, a source file, which is a wave file. So for example, a car engine file. I open it here. We can listen to the sound of this car engine. We can now load the raw file of a transmission computation. For example, the one I have computed for my plasterboard of 8 mm. It's only an example here. This is why it's only 8 mm and only with plasterboard. To hear the sound of the car engine through this plasterboard, assuming that we are in some kind of free field, I just have to click on this icon. When it's yellow, it's computing. Okay, it's down, and now we can compute the sound of the car engine through the plasterboard. And if I want to compute the sound that we will hear in a room through the plasterboard of the car engine, I will have to here choose the impulse response of a room. So for example, I have the impulse response, which is a wave file of a room of 39 cubic meter. So I open it, and now I click on this icon again to make the computation, and you will see this icon change. Yeah, so now I can listen to the car engine sound through a plasterboard inside a room, which is a reverberant room of 39 cubic meter. I will show you in a second how to compute new impulse response, but just a note, if you want to save this configuration to open it later on, just click on Save Auralization, and you just have to choose a text file or create a new one. And next time you open AlphaCell, you can load this text file. Okay, now a question is how do you compute the impulse response of a room? So we can close this, and we can compute impulse response by going into the assembly panel. Inside the assembly panel, we use usually to compute sound absorption coefficient or transmission loss of multiple materials. You now have an option which is to compute the reverberation time of a room. So by default here it's the reverberation time measured in a reverberant room of 39 cubic meter. There's also another room which is available, okay, but I will try this one. And I will say that I have some concrete on the wall of this room, 42 square meter of concrete, and the total surface is 72 square meter. So I will add a melamine foam here of 20 mm on the 30 square meter left. Okay, so now I have 72 square meter for my room. Here is the original impulse response of my empty room, and I can click on this, so I compute in blue the reverberation time of this room, but this time with some walls with melamine. And by clicking on this icon, I will be able to listen to the impulse response of my room with some melamine on 30 square meter. Okay, here is the new impulse response. And I can save this impulse response as a new impulse response.wave file. Okay, save, and I can close this, go back to the Auralization panel, and change, for example, the impulse response for this one. and I have to compute by clicking on this icon to hear the new sound. And of course, if you have multiple configuration, you can click on this button, change the sound, for example, a piano sound, open a rogue file for the transmission panel, the transmission wall, so the plasterboard here again, and I will open the last impulse response of the biggest reverberant chamber. I click on this icon to make the computation of both configurations. Okay, and I can now hear all the sound. The original wave file, the piano through the plasterboard, and now the piano through the plasterboard inside a large reverberant room, which is 411 cubic meter. That's all.